Okay, this is lesson 6.6, determining sinusoidal equations. We can use the general form that we've been using for all of our functions, where f is sin x or cos x to determine the equation of a sinusoidal function. Now, a, k, c, and d, as we've seen in previous units, have always corresponded to stretch, compression, in the case of a and k, and d and c and shifts, whether they're left, right, or up, down. Now, when we're talking about sinusoidal functions, they have additional qualities. Amplitude also represents a. Now, a still represents vertical stretch or compression, but we have a secondary name for it, as it's a secondary characteristic of sinusoidal equations called amplitude. And this is helpful when trying to determine the equation of a sinusoidal function, because we can determine the amplitude by doing max minus min divided by 2. So we'll take advantage of this when trying to find the equations. Just like K and C, K, well, it is the horizontal stretch and compression, is directly related to the period of the sinusoidal function. So as we've looked, period is how long it takes for one complete rotation. Now, the standard sine and cosine graphs have a period of 360. So if we have a new transform function and we compare the periods, we can see whether it's been stretched or compressed. C is also, well, it's still the vertical shift, it's also the equation of the axis. And we can find that by adding the max and min and dividing by 2. And the axis is that horizontal line that runs right through the middle of the sine or cos wave. Now D is still the shift left-right, but it's also called the phase shift. Now, phase shift is dependent on whether you pick sine or cos as your base function. And it becomes, I guess, probably the more challenging part of determining the equation is picking which base function, sine or cos, you're going to use in determining the phase shift. As the amplitude, the k value, and the c value can be calculated, the phase shift needs to be determined without calculation. So just by looking at the actual curve or graph that you're given, or the set of points as you're going to see in that later example. So a couple notes about the phase shift. So when you're determining the phase shift, we do need to pick a base function, either sine or cos, and sine and cos have different base functions. If you're using cosine, you're looking for a maximum point and determining the distance away from the y-axis. Alternatively, you could use negative cosine and look at the minimum point. So what do I mean by that? Well, if we remember what cos looks like, cosine starts at a maximum, comes down, and goes back up to a maximum. That's what one cycle of cos looks like. So if your function appears to start at a maximum, you're probably going to use cos as your base function. If it starts at a minimum, you may use negative cos, just a vertical reflection of cosine. Now, if it doesn't start at a maximum or a minimum, but it's pretty close, at that point you would use cosine, but you'd give it a phase shift. So you'd say, okay, well, it starts pretty close to the maximum. It's only off by, let's say, I don't know, 2 units on the x scale. So it's just cosine, but it's been shifted 2 units left or right, depending on where your maximum is. And we'll see some examples of that. Now, when would you use sine? Well, you'd use sine when the graph appears to start at an equilibrium point. So in the middle of the max and min, sometimes also called the inflection point. Because if we remember what sine looks like, sine starts in the middle, goes up, then down, then comes back up. And it appears to start in between the max and the min, going up. That's what sine looks like. So if your function starts in the middle, going up, then down, then back up, you're probably using sine as your base. If it's the opposite, if it starts in the middle and goes down, then up, then back down, you may use negative sine, which is a vertical reflection of the sine graph. So realistically, we have 4 different base functions that we can choose. Is there a right one to choose? It just depends on who you ask, I suppose. we try to use the simplest equation. So I believe that whichever equation has the smallest d value is probably the best equation. That being said, you could use any of the 4 base functions and write a correct equation of any graph of sine or cos that you're given. In fact, because sine and cos repeat, there's an infinite number of possible correct equations. So for those purposes, we could write many different equations using cos or sine or negative cos or negative sine. It just depends on which base function you're going to use and how far it's been shifted. But the simplest is usually better. So when we do some examples, we'll look for the simplest. All right. So I've recorded a few steps up here, steps that you can use when trying to determine the equation. I usually start with the key characteristics, so amplitude, axis, and the k value, because those can be calculated. Then I look at the graph or the table or whatever information you're given and try to determine the base function. Is it sine or cos? And then from there, you can look to see how far it's been shifted, if it's been shifted from the original parent function. Once you've got your shift, your base function a, k, and c, you can put that information into an equation and you can come up with your final equation. So the first example we're going to do, we have a graph. I'm asking to write 2 equivalent equations for this function. So we'll try to write a sine and a cosine equation. So let's take a look. It says a sinusoidal function has an amplitude of 2 units and a period of 180 degrees and a maximum value of 0, 3. Write 2 equivalent equations for this function. Well, it tells us the amplitude. We also have the graph, so I'm going to show you how we can ensure that we've got that amplitude correct. Remember, amplitude is max minus min divided by 2, and that's recorded at the top. The max is 3, the min is -1. So I know they told us, I'm just going to do the math anyways. Max minus min divided by 2. The max is 3, subtract the min, divided by 2. We do get 2. Our amplitude is 2. It also says the period is 180 degrees. That means it takes 180 degrees to complete one cycle. Now the standard sine and cos take 360, but if we look at our graph here, starting at a max, going down to a min, back to a max, that's one complete cycle. And it takes 180 degrees to complete that cycle. So we do have a period of 180, and if we want to find the k value, we would do 360 divided by the period. In this case, the period is 180. So we have a k value of 2. So now we've got A, K, and C. We can use the maximum value and the minimum value to find the C value. That's the last calculatable variable we still need. So we'll use C. Now C can be found a couple ways. Max plus min divided by 2 is the one I have on the sheet. Sometimes if you're just given characteristics of the graph, like knowing the maximum is 0, 3, and now that we know the amplitude's 2, the C value will always just be down an amplitude from the max or up an amplitude from the min. So down 2 from 3 gives us 1, so we'd expect the C value to be 1. I'll use the one that was given in the at the top of the page though. Max plus min divided by 2. The max is 3 plus the min is -1 divided by 2. We get a C value of 1. And we can see that right there on the graph. It is designated there, y equals 1. That's the equation of the axis. All right, so that's step 1. Step 2 says decide if the base function is sine or cosine. So we're looking to see whether we start at a max or a min or somewhere in the middle. This graph starts at a max. Since we're starting at a max, this graph most closely resembles the cosine function. So one choice is we could choose cos x with a d value of 0 because we haven't been shifted at all. The max is there. That is the shape and starting point of a cosine graph. Now, if we wanted to choose sine, we would have to look at where the function is at equilibrium, or where it's on the axis. And it's on the axis in two spots, 45 degrees and 135 degrees. So it's been shifted 45 degrees, or we've been shifted 135 degrees. Now, since we're on the axis and going down, that would resemble negative cos. So we could say negative sign. So we could say negative sign with a d value of 45. Or we could say sine with a d value of 135. So then we ask ourselves, which equation is simplest? Well, the equation that is simplest here is the one with no shift, a d of 0. So the cosine graph would be easiest to write. Sine, we have two choices. It doesn't matter which one. I'll just go with this one, the negative sine graph. So we'll write two equations here. The first one's going to use cos with no shift, and then a, k, and c. So following the format of a transform function, we get y equals 2 for a. The function we're using first is cos. K is 2 and there's no d, so we can just say 2x plus 1. Next one, if we do negative sine, we get y equals negative 2 sine. That's how we get the negative sign in there. 2 is still k, but this time we have a d value, so be careful. 2x minus 45 plus 1. And there's our two equations. Which one's simpler? Cos. The cos graph was simpler because we had a d of 0. So here's our two equations. How can you easily convert a sine function to a cosine function? Well, we know that a sine function and a cosine function are very similar. They have basically very similar shape. The properties are all a little different, but it's just because we have a shift. The sine graph's been shifted to match the cosine graph, the original sine graph, that is. So how much has it been shifted by? Well, it's been shifted by 90 degrees. So if you want to take your cosine function and convert it to a sine function, we would add a phase shift. 90-degree phase shift. So to do that, let's take a look. We'll take our cos graph and we'll add 90 degrees. Now we know that we should have k common factored, so we'll common factor k. Oops, I should have written sine. I don't know why I wrote cos twice. As soon as we add the 90, we're switching to cos, or switching to sine. We end up with this. Now this doesn't exactly match the one that we have. So is this right? Well, if we take a look at our graph up here, and if we were to continue it backwards, we would have this part of the curve. Now if we remember, sine starts at equilibrium and goes up. So sine graph would be starting here and going up. Where would this be on the scale? Well, that would be, if we're symmetrical, 0 is here, 45 is here, that would be negative 45 degrees. That would be a shift of negative 45. That would be a d value of negative 45, and if we look at our equation, d value negative 45, positive sine graph, we've got it right. So how can you convert between sine and cosine function? You can add a phase shift. Make sure you're shifting in the correct direction with the correct value of d, and you can always tell which value of d by looking at the originals and asking yourself, okay, if I was starting with cos, which way would I have to shift it 90 degrees to get to sine? And if you can match that up, then you can insert that phase shift and common factor k, and then you should have a correct equation of sine. Alternatively, you can just look at the graph and work it out the way we did up here. But there we have it. Okay, let's flip to the next page. So for this one, we're going to be asked to come up with the function just from properties, and then we'll do one from tables. And then there's two graphs at the bottom, and I'm going to leave those two for you to try. And you can, of course, check your answers as these solutions are posted. The sinusoidal function has an amplitude of 4.6, a period of 720, and a minimum at 90 degrees negative 2. Determine an equation of the function. Doesn't say cos, doesn't say a sine, doesn't specify. We can pick anything we want. We don't have a graph this time. We only have 3 characteristics, so we need to use these 3 characteristics to come up with the equation. So let's give it a shot. In the question, we're explicitly given the amplitude, so we're kind of off to a good start. We know A. A is 4.6. We can calculate K because we know the period. K is always 360 divided by the period. So 360 divided by 720 gives us a K of 1/2. We have a minimum at 90 negative 2. So what's that mean? Well, the C value would be in the middle of the graph. And if we know the amplitude, we know how far up from the minimum we would need to go to get to the middle. And if we go up another amplitude, we get to the max. So we can use the amplitude here to find the middle and the maximum. Now we don't need to find the maximum, we just need to find the middle. So for our purposes, C, the middle, is the minimum plus the amplitude. It also works if you know the maximum, you do the maximum minus the amplitude. Our minimum is negative 2. We're going to add 4.6, which gives us a C value of 2.6. All right, we've done the first step. The second step was to figure out which function we're going to use and what the D value is. Now, since we only know one point, we really only have one option. That's to start at that point. So since the minimum is at 90, that means one of the graphs has been shifted 90 to the right, and it could be the graph that starts at the minimum. Now, if we remember from the first page, one of the graphs, one of the parents, does start at a minimum. Cos starts at a max, negative cos starts at a min. So the model we should use here is negative cosine. And the D value we should use is, since we've been shifted 90 to the right, we should use a D value of 90 degrees. So now we've got all the information we need to make the equation. So we can say therefore y equals negative amplitude, so negative 4.6 cos. Inside cos we got to put k of 1/2. Common factored from x minus 90 and plus 2.6. So we've got to follow that patterning of A, F, K, x minus d plus c. So we followed it perfectly. All right, let's do one more. Very similar to the one we just did, except this time we're given more information about the graph. So we're asked for a little bit more here. It says determine a sine and cosine function that satisfies the given data. So we'll try to give both a shot. You could sketch this because we have enough information to draw a sketch. We're going to try to do it just by visualizing the graph and looking at the table. So let's start with A, K, and C as we always do. A is max minus min divided by 2. If we look at the repeating numbers, negative 5 is our smallest and 0 is our biggest. So our max is 0 minus our min divided by 2. We get an A value of 2.5. Max plus min divided by 2 will give us our C value. Max is 0 plus the minimum divided by 2. We get negative 2.5. And that kind of makes sense. From negative 2.5, if we go up 2.5, we get 0. That's the max. From negative 2.5, if we go down 2.5, we get the min, which is negative 5. So that holds true. K. To find K, we do 360 divided by the period. Well, we got to figure out what the period is. How long does it take to go from a min to a min or a max to a max? Well, we've got a minimum here, and the next time we have a minimum is here, from negative 480 to 0. So that's 480 degrees until we repeat. So that means the period is 480. So let's put that on there. We've got a minimum at 480, and the next minimum is at 0. That's how we found the period. 360 divided by 480, that's 3/4 if you simplify in your calculator. You could use 0.75 if you wish. I like fractions for K. Now, I know I used a decimal there. That's kind of weird. Maybe I should have used a decimal. Regardless, I'm going to keep it as a fraction. Okay, now we've got to pick a model. We're going to do sine and cos. The easiest thing to do is to go look at the start. The start of the graph should be at 0, right? And at 0, we're at a minimum. So since we're at a minimum, we could use negative cos, because negative cos starts at a minimum, with a d value of 0. And that would work out. If we want to use sine, we want to see where we're at the axis value. The axis value is negative 2.5. So where are we at negative 2.5? And how far from 0 have we been shifted? So we're at negative 2.5 here and here. If we want to use sine, we're looking for the one that's at negative 2.5 and then the number's going up. So if we want on the left, negative 2.5, we're going down. That would be negative sine. So we could use negative sine. But here we're at negative 2.5 and we're going up. That's the beginning of sine. So if we use sine and a d of 120, we should be able to write an equation. All right, so let's write two equations. Therefore, start with the cos one, negative cos, so negative amplitude, 2.5. Cos, I'm going to change that to 0.75, so I keep it all decimals. That's our k value, 0.75. And no d, so we don't have to write a common factor. We can just write x, and then minus 2.5. There's our first equation. Our second one's a positive sine graph, so we got positive 2.5. Sine, this time we do have a d, so we common factor the 0.75. We get x minus 120. And outside we have our c value, 2.5. There we have it. Two equations of one of cos, one of sine. All right, so I'm going to leave it up to you here for the last two. We've got a picture of a graph. If you can't perfectly read off the shifts, do your best to approximate. A's done pretty well. B's a little trickier because the shift appears not nice and there's no grid line, so it's a little bit trickier to come up with. But if you're close to the same numbers I get in my solutions, you've probably done a really good job, and that would be good enough for me. All right, thanks for watching lesson 6.6. I'll see you next time for lesson 6.7.